Hello and welcome to Dataflow Labs. As discussed during the lectures, Dataflow is completely serverless. It's a managed service for executing unified stream and batch data processing. It's based off Apache Beam SDKs. Apache Beam is an open source unified programming model to implement batch and streaming data pipelines. So as part of the pipelines, you can use a lot of different kinds of input sources and also a lot of output sinks, the standard output sinks that's available. As part of the pipeline, there's two important things: P transform and P collections. The blue line, the blue ones are P transform, which is actually a transformation or some kind of processing operation that you perform on data is called as p transform, and the p collection, it represents a distributed data set on which p transform is applied. Beam uses a lot of different kind of triggers, event time triggers, processing time triggers, data-driven triggers, composite triggers, and it also has a lot of windowing capability to be able to do stream and batch processing at the same time. So examples are like fixed time window, sliding time window, session-based, or calendar-based. And you can run Apache Beam pipelines on different kind of runners. So you can run it locally on your machine. You can use Flink, Spark, and Dataflow, and other runners as part of that. In terms of how the code looks like, this is how you create a pipeline. You import the libraries from Apache Beam, and with clause basically uh, denotes the uh, where the pipeline starts, and then you put different steps, creating a p collection, which is in this case, which is with the piped uh, argument that it's basically reading a file and it's creating a distributed data set off of it. Applying transform tries to apply a transformation on that particular p collection, and applying pardo. Pardos are like the transformation steps using functions. So in this particular case, this is a function which takes length of an element, and that function is being called from the pipeline using part2. Now let's look at the console, and we will try to run some data flow jobs, and I'll show you different ways to do it. So data flow is under big data section. If you come to big data, there's the data flow. And what I'll do is I'll try to run a job through command line first. And also, just because it's based on Apache Beam, so sometimes it's difficult to understand the syntax and everything, but Google provides a lot of examples, So I'll share these two. There's a GitHub link for Google Cloud Platform Professional Services. It's open for everybody. So if you go there as part of example, there are a lot of examples there. There are a lot of examples for different Google services. And this is actually really handy when you are doing lab or when you are exploring Google Cloud Platform. You have a lot of examples for different services, data flow, data proc. So let's say I pick up data flow Python examples. And inside this, you have batch examples, streaming examples. Even if you click on streaming examples, you have cookbook examples. There are there are these pipeline examples. If this particular one is not there. So if you look at this one, so data ingestion. So it's a very extensive code there. You can also look at data transformation pie. So what this could be, this can guide you in terms of how to code or create a pipeline using Apache Beam. For our example today, we will be using the word count.py file, which is a Python file to do the word count, and it's part of the Apache Beam SD examples that's available from GitHub. So this is the particular file. Now, in this file, if we look at this is where, as explained, like with beam.pipeline, this is where the pipeline starts. We will read a file, and then we will do the word count. So this, I'll take an example of a file which has a lot of names. We will extract every name and we'll do a count of each of the names, how many times those names exist in that file. So let me come back here. One thing to note when it comes to uh, Apache Beam, you can run it using different language, Java, Python. There's a bit of support for Scala as well. Uh, so when it comes to Python, so Dataflow only supports Python 3. So you'll have to make sure that you have Python 3 installed. I So by default it has 2. Python 3 is yeah, Python 3 is there. Sorry. Okay. Now, uh, first thing what we will do is like we will install the virtual environment. So venv is the tool which creates a separate Python sort of working area so that it doesn't mess up with your existing libraries or something. So I will install virtual uh, environment first. Create virtual env user. So this has installed virtual env. Now I will create a virtual env and I will name it env. So what I'm doing is I'm creating a separate environment. So everything that we do basically stays, it's a little, sort of like a segregated environment for Python. And then I will source it, source env bin activate. So now you can see I'm working off my own environment for Python. Okay. And it's a very good idea to actually work with Python on mainly on Cloud Shell or any of the shared environment where you have multiple Python versions running. Now, now I will run a sample word count job that I just showed you, the word count.py. Uh, and this uses a default file, which is from Shakespeare, King Lear.txt, and it reads from that file. If you want to know more about this file and how each one of the steps are doing, Apache Beam has a very good description and basically analysis of the entire thing. You can just read through and you would know exactly each and every step. So the entire process is like input text file, which is that particular file. You read from the text file. You pardo, which is the tokenization. You tokenizes on every word, and then you count the frequency of each word. Then you format the word counts and then you write it to the text file. In our case, we'll be writing it to a text file that will be stored on the cloud storage. So it's going to read from one cloud storage, which is where this default file is. It's going to process line by line, word by word, and put it into our cloud storage bucket. So let's run this. Now, the way you run it from command line is there are different parameters. So Python 3 minus m, it's basically referring to the Apache Beam examples word count. Project is your project. Runner is where you pick which runner you want to use it against. And for this particular example, we are using Dataflow. Temp location is the temp folder inside the project that I have, because this is where all the temporary files and everything is created. Then you have the output file, which is where it will be created. Then you have job name. Job name is the name of the job. And then region is where it's gonna spin up the servers. So now let's run this. And what we will see is while it starts running, uh, click on authorize, it will start appearing here. You can also follow through each one of the messages. This particular example does kind of a map and reduce kind of scenario. So if you do go back to your, I think, compute engine, so now you can say it's using state job state running. So it's basically spinning up an instance. If I go back to data flow, so you can see here data flow demo, which is in the green state, and it's actually running right now. So if you click on this, so what you see here is the exact rendering of all of these steps. So it's reading data, splitting the data, is pairing with the words, then it's grouping them and counting the number of words that it exists. And it's a pretty visual way of seeing all of that. You can click on the job matrix. So the job matrix is really useful when you have streaming kind of use cases. You can see how the messages are traveling. You can click on logs. So you will get live logs as and when what's happening in terms of what kind of worker configuration, how many nodes it's instantiating, and what it is executing. And this is all real time. So it's still running. So workers have started successfully. I'll pause it for a couple minutes before it ends. So now it has finished most of the operations and it's actually doing the cleanup. So cleaning up, starting worker pool tear down, stopping worker pool. So if we come to this, now you can see all of these have turned green. That means it has processed everything. If I go back to the storage, the location that we provided, and what you can see here is there's results and the temp. If you go to results, and there are these files. So basically, that entire the it started a service which read all of these files, did all of the map and reduce, and put the output into cloud storage bucket. Now, Google Cloud Platform actually provides you a lot of interfaces to be able to initiate data flow jobs from different places. So I may want to publish this data to Cloud PubSub or push it to BigQuery. So all of these use cases of data processing pipelines. Now either I can go back to Dataflow and try to create a job, and which I will show you how to do it from there. But I also want to show you, let's say this particular example, this one file. You could click on this and you can click on export to cloud PubSub. So what happens if I take this file, let's say, let's take the first part of it. Okay, so put the file in three parts. If I click on export to cloud PubSub, what it would do, it would open up another console where it will have the template ready for me to spin up a data flow job. I can do exact same thing if I come back here and I go to Cloud Data Flow, big data, Cloud Data Flow. And what I can do is I can click on create job from a template. So everything that you we did from the shell, you can do all of that from console as well. What Google provides is Google provides a lot of let's say we call it GCS2 PubSub. Uh, yes, GCS2 PubSub underscore data flow. I'm going to change it to Australia Southeast one. Now, what Google provides is a lot of template for data flow jobs. Um, this was the word count example that we tried to run from the Cloud Shell. Then you have the streaming options where data masking high to, there's a lot of PubSub to BigQuery, PubSub to BigQuery. There's a lot of different options, PubSub to MongoDB. This was added recently. PubSub to PubSub, PubSub to Splunk, PubSub to text file, and then you have a lot of templates for batch processing as well. So Avro files, BigQuery, JDBC to BigQuery, which is really important for bringing data from databases, and you can also plug in your CDC. So synchronizing CDC data to BigQuery. Now for for our case, our files are on cloud storage. So if you click on text files on cloud storage to PubSub, what it will give you, will give you is sort of input fields that it requires. Uh, so input files in cloud storage. So our input files are in that particular bucket. So let me just say I will do star.txt. Okay. Output PubSub topic. So I do have a PubSub topic that I've created before. I'm going to keep this window open. So this is the topic I've created before, Dataflow GCS to PubSub. What I would do is I will take this name. I'm going to put it here. And also in the same example that we have, um, output PubSub topic. So this was when Google is giving you all of those interfaces, and this is for that particular specific file. It gives you exactly same options that you get here. And then temporary location. Temporary location is the location where it's gonna put all the temporary files. That's now if we run this job, the data that we pulled from another storage through data flow running on Cloud Cell, and we put it into our bucket. Now we are trying to stream that data from our bucket to PubSub. So let's see. Let's click on run job and let's see what happens. I'll cancel this window. So this is spinning up. Now in this case, you see, there's just two steps: reading text data and it's writing to PubSub. Uh, if we click on this PubSub, I'm just going to wait a couple minutes. And when this is done, we'll look at the output. So this job has actually failed. And It was on purpose, but because I want to highlight you how better you can observe and how Dataflow actually helps you debug the applications. Now, if you come here, as we talked about before that, the logs is sort of an integrated part of this. So what you can see is like you have a very descriptive sort of explanation what's actually happening, and that you will find at each and every step. So if I cancel this just for better visibility, what you see here is these particular logs. They're basically saying there's no file available with the star.txt under this. Now I can actually go into this, which will take me to a logs viewer, which is part of the Google operations, and you can get much more detail and you can query against the data sets. So this comes into the operations part of it, monitoring part of it, and it actually really helps you with this. So I'll encourage you to actually look at these logs and everything. These are really helpful. More and more experience you get with these, um, because the cloud monitoring and operations, the entire suite of Google is pretty mature. So now let's go back and try to fix the problem. Because this is a serverless component, so what I'll have to do is I'm going to have to clone this. So if I clone it, I get the same examples, but this time what I will do is I will put it was results output star.txt. I believe so. So if I go to storage browser, this part of results, it's part of results. Output star.txt. Yeah, actually, let me take one file, and these are not. These are not txt files, so I will pick the one file. Now, you can also see when you clone, you get a lot of other different options as well in terms of max workers, number of workers, workers reason, because you can have your workers running in a different zone. And Also, it gives you an option to pick the specific machine types, networks, subnetworks, or the service account. So if you want to run these jobs as a specific service account, you can use that too. And all of these configurations, those are an option when you run it from command prompt anyway, because mostly we run Dataflow jobs as in a programmatic way. So you have all of these options to specify. So I'll leave these as is and let's click on run job again. So after waiting for 2 minutes, you can see the GCS2 pops up Dataflow. This job has actually finished. As you can see the green ones, and if we go to pops up, should be able to view the messages. So click on this particular topic, and if I click on view messages, I will pick a subscription. Yeah. So all of these messages that have just come through. So what we demonstrated is you can we We pick data from another cloud storage, use the data flow to pull it into our bucket, and then we did a batch processing into PubSub as a topic. Now, again, from PubSub, you can take it to anywhere. Now, you must have noticed that it's between 2 minutes to 3 minutes. It's because in a batch mode. So when you run a data flow job, it spins up all of the underlying servers to do the processing. Uh, so the startup time and plus the shutdown time, that's all of that is accumulated as part of the runtime. So for a batch processing, which will always be a bit slightly higher, but the main use case is mainly for the streaming ones. Where for first few messages, the startup time will be higher, but after that you have some millisecond sort of response. Also, in this particular example, we read that text file, we are writing it to PubSub, but at the same time, you can write this data into a BigQuery table as well. So data goes to BigQuery, but it also available for others to consume from a PubSub topic. And the way these are done is if you come back to these examples is you can see the output section here, where is the write to text. Similarly, you will have output write using the different IO connectors. So when you are using a lot of different solution, a lot of different output sync is basically you use the specific IO connectors. So you can use another IO connectors to write it into BigQuery as well as part of the same pipeline. So I hope this was useful. Cloud data flow is getting a lot of momentum in the industry. It's also because as long as you get comfortable with writing Apache Beam SDK code, uh, you can abstract away a lot of data pipelining, uh, you know, overhead of managing servers. So you can just concentrate on your logic and let the data be moved across completely in a serverless way. I hope this was useful. Thanks.